Well, we've all heard of AI, right? Artificial intelligence, as it is booming in its capabilities of what it can do. But how does AI relate to weather? It's a big deal. In fact, it's a real big deal in the weather community as computer models. We've got AI weather computer models that are in development, and some of the biggest companies are onto this, including Google and Microsoft, for example, all working on AI weather computer models. These are some of them that are currently in progress, including the European, what's called the AIFS. Pangu Weather is another one. We'll talk about NATOcast here in a minute as well. That's on X, formerly known as Twitter. So let's talk about this here. What are AI computer models? How do they differ from our current computer models? And, well, is it about to take our jobs and overtake everything? Let's talk about it. So AI computer models run much faster than a traditional numerical weather prediction computer model. And right now, with traditional models, all the data is put in, and these are math and physics equations that simulate the state of the atmosphere. All of those equations go through these supercomputers, and it can take hours to get the result of what that model thinks is going to happen over the next couple of days. These AI models run much faster because it doesn't rely on all of these complex mathematical equations. I'll get to more on that in a moment. Most of the AI models right now are fairly low resolution. And when we're looking at computer models, we're looking at different grid spacings. Now, right now, it's about a 30-kilometer resolution with AI computer models. That's pretty far apart. When we're talking about thunderstorms and thunderstorm scale, we want to be on the 1, 2, or 3-kilometer scale when we're looking at very fine details of a storm system or something like that. So bottom line is, right now, it's not great with extreme weather. It's okay with the broad stuff, but it's not real good at drilling down and looking at lake breezes or thunderstorm development or something like that. So AI models are showing a lot of promise, including this NATOcast model that is available for free on X, formerly known as Twitter. That's raised a lot of eyebrows. What it shows is basically the area that could see the greatest risk for tornadoes on a given day, and they do like a 2-day forecast. And that's something in the weather community that we've looked at a bit more, and it's actually shown a lot of promise and shown quite a bit of skill with that. So that is more on the lower scale in terms of resolution, or the greater scale, I should say, of resolution. Now, the current computer models use physics and math equations. You may have heard of the American model, right? The GFS, the Euro or the European. There's the NAM, and there are several other models as well. AI models use neural networks and machine learning to forecast. So what these AI models are doing is, well, they're taking a first look at the atmosphere, and then they are simulating that out 6 hours, and they're taking that and doing another 6 hours, and so on and so forth, to go out several days. So you're not using the math equations and the physics equations here, but what you're doing is you're using the machine learning and the neural networks to do it. So it's a different, faster process, and then each time it runs, it's kind of learning off of each other, right? So here's the bottom line when it comes to AI. Are AI computer models going to take over our jobs and take over the weather anytime soon? The answer is no. Is it making rapid progress? Yes. But here's the deal. Much like the traditional computer models, AI computer models spit out various solutions. So it's not to say that all AI computer models are going to be correct. Just like the standard computer models often aren't correct. It takes analysis on the human end to look at that and say, okay, which model do we think is best in a snowstorm or in a thunderstorm? That type of a thing. The human analysis is still very much required for all of this. Now, maybe a decade down the road, maybe that starts to change. But right now, we are nowhere near where AI computer models are extremely accurate at this point. Now, I think it'll continue to get accurate with time. It will continue to supplement the forecast process here, but we often call it computer model guidance. And the reason why we do that is because you don't want to take a computer model at its word. It takes that human analysis to be able to peel those layers back to figure out a weather forecast. And I think AI is showing a lot of promise, and I think it's going to be a game changer in the weather world, but at least as of now, I don't see it replacing human meteorologists.